Hello friends, welcome to my YouTube channel. In today's video, we're diving into how to use Python blocks with vectors in GNU Radio. Let's start. Contents. 1. Starting the flow graph. 2. Accepting vector inputs and outputs. 3. Indexing streams. 4. Indexing vectors. 5. Creating max hold function. 6. Multiple vector ports. 7. Conclusion. Introduction. This presentation describes how the Python embedded block can be modified to accept vector inputs and outputs, and how the input_items vector indexing is different between vectors and streams. Starting the flow graph. Add the blocks to the flow graph. Signal source. Throttle. Stream to vector. Embedded Python block. Vector to stream. Qt GUI times sync. Virtual sync. Virtual source. Variable. Change the block properties. Signal source. Output type, float. Frequency, 100. Variable. ID, vector length. Value, 16. Stream to vector, number items, vector length. Vector to stream, number items, vector length. Virtual sync, stream ID, sinusoid. Virtual source, stream ID, sinusoid. Qt GUI times sync. Autoscale, yes. Number of inputs, 2. Connect the blocks according to the flow graph as shown in Figure 1. Accepting vector inputs and outputs. The embedded Python block needs to be modified to accept vector inputs, produce vector outputs, change the data types to float. Since the case of streams is so common, it has its own simple syntax, whereas the syntax for vectors is just a bit more complex. In particular, when using vectors, we must specify the vector's length along with the data type of the elements in the vectors. We do so using a tuple in Python, as shown in Figure 2. Change example_param in the function definition to vector size. Def__init_self, vector size equals 16. Change the name. Name equals max hold block. Define the input and output vector signals using a tuple. In_sig sadface np.float32, vector size. Out_sig sadface np.float32, vector size. Remove the self.example_param equals example_param line. Remove the multiplication by self.example_param. Indexing streams. For a stream, inputs and outputs can be indexed using both the port number and the sample index. Indexing based on the port number returns all of the input samples for a specific port. For example, input_items 0 returns all input samples on port 0. The following line returns the fourth input sample on port 0. Input_items 03. The indexing for streams is generalized to input_items, port index, sample index, output_items, port index, sample index. The image shows how to visualize indexing streams as shown in Figure 3. Indexing vectors. The input_items and output_items include an extra dimension when using vectors. Vectors add an additional dimension, represented as vector index below. The input_items and output_items are now three-dimensional arrays. Input_items, port index, vector index, sample index, output_items, port index, vector index, sample index. Indexing based on the port index returns a two-dimensional array of all vectors and samples. For example, input_items, port index, output_items, port index. Indexing based on port index and vector index returns a single-dimensional array of samples. For example, input_items, port index, vector index, output_items, port index, vector index. Indexing based on port index, vector index, and sample index returns a single sample. Input_items, port index, vector index, sample index, output_items, port index, vector index, sample index. A visual example vector indexing is given in Figure 4. Creating max hold function. The work function is modified to include the max hold function. Add a loop over all of the vectors in input_items 0. For vector index in range len input_items 0. Calculate the max value of the vector. Max value equals np.max input underscore items, 0, vector index. Loop over each of the input samples. For sample index in range, len, input underscore items, 0, vector index. Assign each output sample max value. Output underscore items, 0, vector index, sample index, equals max value. The code should look like in the figure 5. The output shown as in figure 6, a sinusoid and a sinusoid with a max hold applied every 16 samples. Multiple vector ports. The max hold block is modified to add a second vector input and output port. Add the following blocks to the workspace. Noise source. Stream to vector. Vector to stream. Virtual sync. Virtual source. Qt GUI times sync. Change the following block properties. Noise source. Output type. Float. Stream to vector. Number items. Vector length. Vector to stream. Number items. Vector length. Virtual sync. Stream ID. Noise. Virtual source. Stream ID. Noise. Qt GUI times sync. Autoscale. Yes. Number of inputs. 2. Connect the blocks as shown in the figure 7. As shown in the figure 8, edit the code for the max hold block. Add a second vector input and output. In underscore sig equals np.float32, vector size, comma, np.float32, vector size. Out underscore sig equals np.float32, vector size, comma, np.float32, vector size. The work function is modified to perform the max hold function over both input ports. For port index in range, len, input underscore items. Change all indexing 0 to port index, as shown in figure 9. For port index in range, len, input underscore items. For vector index in range, len, input underscore items, port index. Max value equals np.max, input underscore items, port index, vector index. For sample index in range, len, input underscore items, port index, vector index. Output underscore items, port index, vector index, sample index, equals max value. Save the code and connect the blocks as shown in the figure 10. Run the flow graph. 2 max hold outputs will now be generated, one for the noise source and one for the sinusoid as shown in the figure 11. Conclusion. In this presentation, we learned how to use Python blocks with vectors in GNU Radio. We covered starting the flow graph, handling vector inputs and outputs, and working with streams and vectors. We also created a max hold function and explored using multiple vector ports. By understanding these basics, you can now start using Python blocks with vectors in your own projects. Thank you, friends. Goodbye and see you next time.